Hello everyone. Hope so you're all doing good. In today's session, we are going to discuss Cambridge IGCSE exam physics paper 2 and paper code 0625. Yes, we will start from question number 1. In question number 1, the question states which list contains two scalar quantities and two vector quantities. We are supposed to choose among the four options which one has two scalar quantities and two vector quantities. The first one, if you see, yes, distance is a scalar quantity. Speed, distance by time taken, is also a scalar quantity. Time taken is also a scalar quantity. Yes, velocity is a vector quantity. It has both magnitude and direction. But the given question is asking for two scalar and two vector quantities. Hence, option A is ruled out. So if you see the option B, force F is equal to ma is a vector quantity. Velocity has both direction and magnitude is a vector quantity. Distance is a shortest distance between final to initial position is a scalar quantity. Mass is also a scalar quantity which remains constant universally. Clear? So hence for the first question option B, like it contains two scalar quantities, distance and mass, and two vector quantities, force and velocity. Yes. And the second question, the diagram shows the speed time graph for a car. Okay. If you look into the diagram, y-axis speed, x-axis time. Okay, which row describes the motion of the car at the point X and at the point Y. So at the point X, if you see, the object is not at rest. Okay, the object is not at rest. The speed increases. Okay, the speed increases at the point X. Like it's a changing speed generally. So if you see here, this is ruled out constant speed. Yeah, these two may be the options. Okay, now we'll come for Y. The object Y, like at the point Y, it's not at rest. You can see here the body is maintaining a constant speed. The speed remains constant in y-axis. You can see here time only increases, speed remains constant. So this is wrong and the correct option is option D is a correct option. Yes. And the next question, third question. Four objects are moving in a straight line. The table shows the distance moved by each object in each second of its motion. Which object is moving with constant non-zero acceleration? So there should be a constant acceleration. So option A, if you calculate the acceleration, that is change in velocity by time taken. Option A, the change in velocity is becoming zero. Like change, no, not change in velocity. It's actually distance moved. Distance moved. If you calculate the change in distance, nothing but velocity. So change in displacement by time taken. So change in displacement is 0 in the first case. Okay, so 5 minus 5 divided by the time will come. So option A is ruled out. And option B, if you see, there is a change in velocity. So velocity changes by 6 minus 1 by 1 v1 and 7 minus 6 by 1 v2 and 8 minus 7 by 1 v3. So the velocity is uniform and hence it maintain a constant non-zero acceleration. Option B is a correct option. And the fourth question, the drag force of a car increases. The drag force, what is meant by drag force? I have a car, okay. So which is moving, okay. The drag force is a force which is acting in the opposite direction. It may be the air drag force or floor drag force, anything. The drag force is acting in the opposite direction and the drag force increases. If the drag, that's what given in the question. The drag force of the car increases. Applied force is different, drag force is different. The drag force increases at with some speed, okay. At 20 meter per second, the total drag force is 400 Newton. Mass of the car given and the driving force is also given. So what is the net accelerating force of the car will become driving force minus the drag force. So this will be 300 and this is the net accelerating force. This is the net accelerating force. That is F is equal to 300 Newton is a net accelerating force. Okay. But the question they are asking which statement about the acceleration. So what is the acceleration of the car? Mass into acceleration. Mass is given as 1200 and acceleration I'm supposed to find out. So if you find 300 by 1200, we will get 0.25 meter per second square as the acceleration. Or there are two options, this or this, option A or B. It's clearly given the drag force increases, hence the driving force will be decreasing. Option A is a correct option. Acceleration we got 0.25 meter per second square. As the drag force increases, the driving force decreases. Option A is a correct option. And the fifth question, a rectangular swimming pool is there of length, breadth and also depth, nothing but the height is given. Density of the water given. What is the mass? We know that density is equal to mass per volume. And mass of the water in the swimming pool will become density multiplied by volume, which is 1000 multiplied by volume. Volume of the swimming pool is nothing but length into breadth into height. So if you solve this, we will get the answer as option D. So 2500, 1000. Okay. Option D is a correct option for the fifth question. And the sixth question, an object is rising vertically at a constant speed. This is the keyword. Through the water. There are three vertical forces acting on it. Weight. Weight of an object will always act in the downward direction. And clearly the question says that the object is rising vertically. it's rising. So the drag force will be there in the opposite direction. Clear? So these two options are ruled out because the drag force is given in this direction, which is wrong. So we need to choose among C and D. Will come. Okay, which diagram shows the magnitude and direction of the vertical forces acting on the object? It is moving with constant speed. So the net to force is zero. Constant speed means net to force is zero. The net force acting on the object is zero. So if you see these two cases, upward force is 2 Newton, downward force, that is due to weight and drag force, will become 4 Newton. These two are not equal. So option C is ruled out. And if you see the option D, upward force is 3 Newton and the downward force is also 3 Newton. Hence the correct option is D. And the next question, two boys of equal weight. So it's clearly given these two boys have equal weights. Sit on one side of a seesaw. Their father of weight 1000 Newton sits on the other side 1000. Okay. The seesaw is balanced. Keyword. So if it is balanced, it is in equilibrium condition, and we know that at equilibrium condition or the balanced condition, force acting on one end multiplied by the distance will be equal to the force acting on the other side multiplied by the distance. Okay. So what is a force acting on one side? Okay. So is being used so that it moves ups and down. Okay. During one part of the cycle, the father descends through a distance of 40 centimeter. At the same time, the body nearest to the pivot rises through 20 centimeter and the other boy rises through 80 centimeter. So F1 1000 Newton, and what is the distance he is located? 40 centimeter. That's what given. That is a father, which should be equal to. So it's clearly given in the question that both the boys are having equal weights. So let me take it as X, and the first boy is moving through a distance of 20 centimeter plus the other boy weight, which is also X, and he is moving at a distance of 80 centimeter. So I can write this as 40,000 is equal to 80 plus 20x 100x. And when I calculate for x, that is the weight of each boy, will become 400 Newton. Option B is the correct option. Hope so you got it. And the eighth question, a student measures the length of the spring. She then attaches different weights to the spring. She measures the length of the spring for each weight. Okay. The result of her measurements is so shown in the table. What is the extension of the spring with a weight of 3 Newton attached to it? So they are asking the extension of the spring when she is loading 3 Newton. Look at the data given. When there is no weight, the extension of the spring is 520. I have a spring, there is no weight, the extension of the spring is 520. The initial distance is 520. When I'm loading some weight, that is 3 Newton weight, when I'm loading some 3 Newton, the length of the spring getting expanded and it increases by 13 centimeter because 533 minus 20 will become 13 centimeter. The length of the spring increases by 13 centimeter. So for eighth question, option D is a correct option. Hope so it's clear. And the ninth question states the momentum of a body is changed by a force acting for a period of time. Okay. Which action increases the change in momentum? Now, before going to this, what is the relation between force and momentum? Hope so you know this. We are getting this relation from Newton's second law. That is, a force acting on an object is directly proportional to the change in momentum with respect to time. Newton's second law of motion. So according to that, if you see the option A, doubling the force, if the force is doubled, so change in momentum and the halving the time, if the time is half, then the change in momentum will be actually which action increases the change in momentum they are asking. So if you solve this, it will be 2 by t. So 2 like change in momentum remains constant. If you solve this, the change in momentum remains constant means there is no change in the momentum. So option A is ruled out. And doubling the force, if I double the force, okay, at the same time, which is equal to dp by dt. Time remains constant and only the force is increased and this will increases the change in momentum. Option B is a correct option. And the 10th question, the equation used to find the change in gravitational potential energy of an object can be written as gravitational potential energy is mgh delta h, change in height. Okay. Now we can find our answer. Y will be mass and G is a gravitational field strength. Nothing but Z. So option A is a correct option. And the 11th question states a machine has a power output given and the power input given. Output power I am supposed to calculate and the given question is asking for efficiency. We know that the efficiency of a machine will be output power divided by input power. So what is the output power? We need to calculate as energy by time taken and the input power is 200 watts which is given. Energy is 1 kilojoules in 6 minutes convert into seconds divided by 200. So if we solve this, we will get 1 by 36 into 1 by 2 which is 1 by 72. So 1 by 72, if I solve this into percentage, I will end up with option C. Okay, so this I will get it as 0.014 and then if I'm converting into percentage, then I will get 1.4 percentage. And the 12th question is, it's a simple one. The unit of power is watt. Option D. And 13th question, the diagram shows a rectangular block of weight 60 Newton. It is resting on a flat surface. Okay. What is the pressure at the base of the block due to its weight? So what is the pressure? We know that pressure exerted by any object will be rho GH. But density is not given. Rho can be written as mass per volume into GH. So what is the mass? Mass into G. Mass into G I can say as weight, which is given as 16 into the height is 9 centimeter divided by volume is length into breadth into height. So if we solve this, for 13th question, we'll end up with option C, 0.80 Newton per centimeter square. So what is the pressure at the base of the block due to its weight will be 0.8 Newton per centimeter square. So for 13th question, option C is a correct option. And the 14th question, an oil tank has a base area given. It's filled with the oil at a depth is also given. Density is also given. What is the force exerted on the base of the tank due to the oil? What is the force exerted on the base of the tank due to the oil? Okay. So we can say force pressure is equal to force per unit area, and force exerted on the base will be pressure into area. So how to calculate the pressure? Pressure will be rho GH multiplied by area. So rho is density 800 kg per meter cube. G is the gravity, let me take it as 10. And height is nothing but the depth 1.2, and the area is also given, which is 2.5 meters square. So when I solve this, I'll end up with 24,000 Newton, option D. So for 14th question, option D is the correct option. And for 15th question, a sample of gas is trapped into a rigid container. Okay, it's a rigid container. Actually, it's trapped. Fully it is trapped. As the temperature of the gas is increased, the pressure increases, because we know that PV is equal to nRT, ideal gas equation. As the temperature increases, pressure increases. Which statement is not correct? The gas molecules have the greater kinetic energy. Yes, we know that. As the temperature increases, kinetic energy increases. This statement is correct. The gas molecule hits the walls of the container harder. This is also correct. The gas molecules, because they started with move high kinetic energy, hence they hit the walls is harder. The gas molecule hits the walls of the container more frequently. This is also correct, because all particles started to move. And option D, the gas molecules move further apart. This is wrong. They started to move, yes, true. They started to move vigorously as the temperature increases, kinetic energy increases. But it's a rigid container. They cannot go out of the container. All particles will be staying inside the container. They cannot move for a longer distance, like they cannot move further apart. So option D is a wrong statement. So for this question, option D is the answer. And the 16th question, what happens when the temperature of the liquid increases? As the temperature of the liquid increases, so again I am taking my ideal gas equation. As the temperature increases, the volume of the liquid also increases. So these two may be the option. As the volume increases, the liquid will become less dense. Okay. So more dense is a wrong option because density is equal to mass per volume. As the volume increases, density should be decreasing. So option C is a correct option. So what happens when the temperature of the liquid increases? The volume of the liquid also increases, making the liquid less dense. Option C is a correct option. And the 17th question, a bar of metal which is a good thermal conductor is heated at one end. Okay. What is the main method of transfer of thermal energy along the bar? So lattice vibrations will be there, but it won't transfer the thermal energy mainly. The thermal energy will be transferred one and only due to the transfer of electrons. When the metal is heated, the electrons will be moving from one place to another place. Hence, the transfer of thermal energy will be there from one part of a conductor to another part. Option C is a correct option. And the 18th question, a transverse wave moves along a rope. Okay. The diagram shows the position of the rope at one particular time. Okay. Which two labeled points are one wavelength? So if you see option A, W and X, W and X is not possible. Wavelength is the distance traveled by one complete wave or distance between two consecutive crest or consecutive trough. Anything. Both the options are correct. But the first one is completely wrong. And W and Z. So W to Z, if you see, there is nothing like no complete wave. So this is also wrong. And X and Z. So X and Z is a complete wave. Hence option C is a correct option. Hope so you got it. And the 19th question. Light in transparent plastic meets the boundary with air. Light is transmitted into air only if the angle marked theta in the diagram is greater than 36 degree. For total internal reflection to happen, the angle of incidence should be greater than C. Okay, but this is not total internal reflection. The ray is traveling in the boundary. So we know that the refractive index will be equal to 1 by sine C. How can I say this is the critical angle? Because it's clearly given the ray is traveling on the boundary. So hence the angle should be equal to, that is angle of incidence should be equal to C. If it is greater than C, it will be internally reflected, but that's not given in the question. So the ray is traveling in the boundary. So angle of incidence is equal to the critical angle. But what is the angle of incidence? Is this the angle of incidence? No, because angle of incidence is measured like with respect to the normal. Angle made by the incident ray with respect to normal, I need only this angle which gives me the angle of incidence. And in this case, angle of incidence will be equal to critical angle. So to calculate this angle, I need to do angle C will be equal to 90 degree minus 36 degree, which is 54 degree is the critical angle. And they are asking in the given question, they are asking the refractive index. So refractive index is equal to 1 by sine 54. If you do for sine 54 in calculator, and you will get option C. 1.2 is a refractive index of plastic. Fine. And the 20th question, a thin converging lens has a focal length of f. An object O is placed to the left of the lens. Okay. What is the correct image formed and how does its image size compare to the object? Object is between optical center to the top focus, because clearly the diagram shows object is between center of the lens to focus. This point is called focus. For this case, if you're trying to draw the ray diagram, so we'll get the image as a ray passes parallel to the principal axis, must passes through the focus. This is the focus, okay. So if you're retracing this line, and also a ray passes through the optical center, remains undeviated, like it just passes away. And this should be a daughter line. This is not the original one. Daughter line should be there. And hence this is your image. So if you see this, among the four options, the image is appearing on the same side of the lens, not the opposite side. Opposite sides are ruled out. Same side of the lens, correct? And it's a larger in size. Hence, option C is a correct option. Option D gives it smaller size. That's not true. Actually, the image is enlarged, erect. It's not a real image. It's erect and virtual. So it's enlarged, erect and virtual. Hence option C is the correct option. 21st question, which diagram shows what happens when a ray of light passes through the prism? Um, Here the option A, after entering into the prism, like the light is traveling from air medium to glass medium. So from air medium to glass medium, the speed increases. Sorry, speed of light in air is 3 into 10 to the power of 8 meter per second, whereas in glass it will be 2.2 or something. Depends upon the material, but it's slightly lesser than air. The speed decreases. So hence here itself, all the constituent colors in the white should take its own path. That is not given in option A. So this is completely wrong. So if you see this light is traveling from rarer to denser, it should bend towards the normal. So normal is here. Normal is here. It should bend towards the normal, but that's not shown here. Hence, this is also wrong. So hence, the correct option is option D. And here, if you see here, it's going the other side, like from glass to air. It has to bend. So rarer to denser medium bends towards the normal, denser to rarer it bends away from the normal. So that condition is not satisfied. So option D is a correct option. And question number 22. A TV station transmits a signal to a television receiving dish. The television has on-off indicator light. The television is switched on by a remote control which changes the indicator light from red to green. Which electromagnetic wave is used in this action has the longest wavelength? So if you see the point A, in TV stations, in TV station radio waves are used, and in a remote station infrared rays are used, and this is an electromagnetic wave CND. Okay. If you see this, Rahul's mother is visiting Uncle Xavier's garden. Like you can remember the order of the spectrum using a simple sentence. Rahul's mother is visiting Uncle Xavier's garden. Radio waves, microwaves, infrared, visible, ultraviolet, X-rays, gamma rays. This will be increasing frequency order. Okay. And decreasing wavelength. So they are asking the longest wavelength. So longest wavelength is radio waves. Option A is a correct option. Longest wavelength is radio waves. Option A is a correct option. Okay. The 23rd question. A student makes a list of some applications of waves. Which application use ultrasound waves? We know that ultrasound waves has a frequency above 20 kilohertz. Above 20 kilohertz. These sound waves are said to be ultrasound waves. So we know that ultrasound waves are used to find the ocean depth sonar, and it is also used to find, that is a scanning of soft tissues. Yes, but in sterilizing water we will be using ultraviolet rays, which is ruled out. Hence option C is the correct option. 1 and 3 we uses ultrasound waves. And the 24th one, the diagram shows a bar magnet at rest. Okay. On a smooth horizontal surface, the length of the soft iron wire is held perpendicular to the magnet. Okay. The wire is released. Okay. The wire is released. Now what happens? So when the wire is released, okay, I have a soft iron wire. When the wire is released, it's iron wire. The wire will move towards the magnet because magnet will attract the iron particles. So the magnet will move towards the magnet is a correct option. On the 25th question, which diagram shows the electric field pattern? Like static charges produces electric field, And they are asking for a positive charge. So positive charge, it will be radially outwards. Positive charge radially outwards, negative charge radially inwards. They are asking for positive charge. It should be radially outwards. Option A is a correct option. And the 26th question. A laboratory has a standard wire of known resistance. It also has a other wire. So standard resistance, let me name it as R. And other wires made from the same material, means specific resistance of these two wires remains same, but of different length and diameters. Which wire would definitely have a resistance of less than the standard wire? That means the new wire should have less resistance. To solve this question, I should know the relation between length and area of cross section to that of the resistance, and it will be R is proportional to length, that is directly proportional, and inversely proportional to the area of cross section. So according to that, if the length increases, resistance also increases. But in the question, we want the resistance to be shortened. So the length should be shorter, yes, and the area should be larger. Hence, option C is a correct option. If area is larger, resistance will become less. They are asking for less resistance. Hence, option C, which states length is shorter, diameter larger, is a correct option. And for 27th question, the graph below shows the relationship between the current in a circuit component and the potential difference. Okay. The graph has a straight section. So this is the straight section, and a curved section is also there. Okay. What happens to the resistance of the component in these two sections when the current increases? So this part is said to be perfect ohmic component which completely obeys Ohm's law, which states that I is directly proportional to V, Ohm's law. As VI graph is a straight line, Ohm's law is applicable only to this part, which states I is proportional to V. So in this part, as a current increases, voltage also increases. Hence, the resistance remains constant only in the first part. So no change in resistance will be there in the straight line path. And when you come for curved path, as a current increases, this region is a non-ohmic part. Ohm's law is not applicable because it's a curved one. Current versus potential difference graph is a curved one. Ohm's law is not applicable. So in this region, current increases. As a current increases, resistance decreases. Okay. No, as a current increases, as a resistance decreases, current will be increasing. Okay, so resistance as in this section, as current increases, so its resistance also should increases. So V is equal to IR. As a current increases, resistance also increases. So for this question 27, option D is a correct option. And 28th question, So what is a combined resistance? So if you see here, these two are connected in series. The total resistance in series will become 3 ohms, and which is in parallel with 4 ohms resistor. So 1 by Rp will become 1 by 3 plus 1 by 4. When I solve this, it will be 4 plus 3 is 7 by 12. I can say Rp will become 12 by 7. So 12 by 7 is option C. 1.7 ohms is a correct option. And 29th question, diagram is given. The voltmeter reads 6 volt, which is connected across 10 ohms resistor. What is the potential difference across 30 ohms resistor? So what is the potential difference across 30 ohms resistor? That's the question. So in order to measure this, I should know the total current across these two. Total current across 10 ohms I can calculate. And in series connection, current across each element remains the same. Okay, so what is the current across the first one? V is equal to IR, I is equal to V by R. This is the current. So 0.6 amperes is the current along 10 ohms resistor, and the same current will flow via 30 ohms because this is series connection. So what is the potential difference? V is equal to I into R, and this will be 18 volt. Option C is a correct option. And the 30th question, a wire is moved down in a direction perpendicular to the magnetic field. Here is a wire. 3 changes are suggested. Which change increases the electromotive force? So the EMF will be increased by increasing the speed of movement of when there is a relative motion between a coil and a magnet, EMF is induced. This phenomenon is called electromagnetic induction. So the EMF to be increased, sorry, EMF to be induced, we need to increase the speed of movement of when there is a relative motion. There is no relative motion, nothing will be there. So if the motion is speed, yes, EMF will be large. So one, that is speed of the movement of the wire should be increased, correct? And the field strength is decreased. No, the field strength should be increased. If I'm decreasing the field strength, I won't have much EMF. So second one is wrong. The direction of the magnet is reverse. So this is not going to increase the EMF. This will just change the direction. So EMF cannot be increased. So for the 30th question, option B is a correct option. Like first one is only correct. The 31st question, a wire is moved across a magnetic field. Okay. When there is a relative motion between the magnet and a conductor, EMF will be induced. Okay. This causes an induced current in the wire. The induced current interacts with the magnetic field to produce a force on the wire. In which direction is the force? So will it be in the same direction of force or in the opposite direction? So the force should be opposite to the movement of the wire, because according to Lenz's law, the EMF will be opposite to the magnetic flux. EMF will be there, that will be opposite to the magnetic flux. So in which direction the force will be there? The force will be opposite direction to that of movement of wire. Option D is the correct option. And the 32nd question, a 100% efficient step down transformer has a primary, it's a step down transformer. So whatever may be the primary voltage and secondary voltage, it is being stepping down. So the number of windings are less. Stepping down. Okay. Voltage, primary current. Which row compares the secondary voltage with VP and the secondary current with IP? So secondary voltage, it's a step down transformer. Secondary voltage should be down, like it should be less. And we know that in a transformer, power input like VP IP should be equal to VSIS. The power remains constant. Input power will be equal to output power. Yes. Power remains constant in transformer. So input power is VPIP and the output power is VSIS. Power remains constant. So according to that, if there is less VP, IP should be greater so that the power remains constant. So according to that, which option? C is a correct option, which will have less VP and also greater IP so that power remains constant. Clear? And the 33rd question. The scattering of alpha particle by a thin metal foil supports the nuclear model of an atom. Why alpha particles are used rather than neutrons? Alpha particles are nothing but helium-24. So neutrons are nothing but neutrally charged. So we need a particle which is positively charged. Then only we can study like which is like the particle is being attracted towards the charge or away from the charge. So we need a particle which is charged, but neutrons are zero charge, neutrally charged. So for 33rd question, helium, that is alpha particles have positive charge, is a correct option. And for 34th question, iron nuclide is represented this way. Okay. So actually this is mass number and this is atomic number. So this is A mass number, this is atomic number. So atomic number will give me the number of protons or number of neutrons, which is 26. Yes, this is correct. Nucleon number, no, neutron, the number of neutrons is only 30, not the nucleon number, wrong. The nucleus contains 56 neutrons, no, it contains 30 neutrons, this is also wrong. Hence the correct option is D. The 35th question. A sample of radioactive isotope has an initial rate of emission of 128 counts per minute. That is initially N0 is 128 counts per minute. Okay. And a half-life of 4 days. How long will it take for the emission for the count to be? Okay. In T half, like in half-life, it will become N0 by 2, that is 64, and 2T half will become 32. 3t half will become 16. And okay. So 35th question. T half is 64. 3t half is 16. They are asking 30 to count. 30 to count is possible when the time period is 2t half. T half is given as 4 and 2t is 8. Option C is a correct option. Option C is a correct option. 36th question. So scientists were working in a laboratory. Okay. Which safety action rules for the protection against the ionizing radiation should be taken? So they should stay behind the lead lined screen. Yes, true. Do not stay longer than 4 hours per day. Yes, true. Keep at least 2 meters from the other people. No, this is not required. Other people, no. We need the prevention from the ionizing radiation. Hence option 2 and 3, that is option D, is a correct option. And 37th question. Which data is needed to calculate the average speed, sorry, orbital speed? Orbital speed will be distance traveled by time taken. So we need the distance and the time period to calculate the orbital speed. So yes, we need the distance, true. Which data is needed to calculate the average orbital speed of a satellite around a planet? We need a distance and the radius of the planet and the time period of rotation, we don't want, but the time for the satellite to orbit the planet is required. So T is required. We don't want the radius of the planet, but we need the radius of the orbit. We don't want the radius of the planet, but we need the radius of the orbit. So this we don't want, radius of the orbit only we want. And this is also we don't want. And time for, yes, the complete time period we need. Option B is a correct option. The 38th question. How long does it take for the moon to make one complete orbit? It's not 24 months, sorry, 24 hours. And yes, it takes 1 month. It takes 1 month for the moon to orbit. Half moon and full moon you will have in every 15 days. So for 38th question, option B is a correct option. And for 39th question, the energy generated in stable stars. So we know that the nuclear reaction inside our sun, hydrogen is converted into helium nuclei. So that is two hydrogen nuclei combine together to form He24 helium nuclei. Option D is a correct option. And for last question, the 40th question, Hubble's constant H0 will be equal to V by D. That is the speed in which it is moving away from us and the distance of the galaxy or any object from our Earth. So according to this, V is directly proportional to D. Yes, V is directly proportional to D, correct? And if you estimate the current Hubble's constant value, which will be this one. So option A is a correct option for 40th question. Yeah, that's it. We finished all question. Hope so it's clear. We'll end up the session. Thank you all.